In this video, we'll be looking at some thermochemical laws. It is important to be able to determine the enthalpy change of a reaction to predict whether the reaction is going to be feasible or not. We need to know how much heat is going to be produced, and these thermochemical laws will help you to do that. Now, the first one says that any thermochemical equation can be reversed provided the sign of the enthalpy change is reversed. The magnitude, however, should remain the same. And so when we have A to B with an enthalpy change of X kilojoules per mole, now we can alter this and have B to A. This is allowed. However, you should also remember to change the sign of the enthalpy change. So if this was positive, because we are reversing this equation, it should become negative X kilojoules per mole. So you notice that the magnitude of the enthalpy change is the same. However, the sign has changed. Okay, now the mole is also important. So when you are multiplying any of this equation by a coefficient or a factor, then the same thing needs to be applied to the enthalpy change as well. So if I take the second equation and I decide to multiply through by 2, meaning I'll have 2b giving me 2a, the same thing has to be done to the enthalpy change. So I'm going to have 2 times the enthalpy change, which is going to be minus 2x kilojoules per mole. So that is the first law that you have to take note of. And the second one is Hess Law of constant heat summation. Hess Law of constant heat summation. Now this one says the total enthalpy change of a reaction is the same regardless of the number of steps in which the reaction occurs. Now we can also put this in a different way to say that it is the same thing, but it can also be put in a way that if a reaction occurs in several steps, the enthalpy change of the overall reaction is the sum of the enthalpy changes of the individual steps. So we may want to carry out a reaction and we don't know how much heat or the enthalpy change that is involved. Now this suggests that we can find other reactions and identify their enthalpy changes, and we will be able to utilize that to determine how much heat is going to be involved in what we are going to carry out. So for example, we can consider the enthalpy or formation of carbon dioxide. So if you take carbon dioxide CO2, we can have solid carbon being burnt with a half mole of oxygen gas, and we are going to have carbon monoxide CO, and let's say the enthalpy change here is delta H1. And if we take this carbon monoxide and again with 1/2 moles of oxygen gas, we are going to have carbon dioxide gas CO2. Now let's say the enthalpy change here is delta H2. Now we can have solid carbon with oxygen gas O2, and this would also give us CO2 gas. Let's say the enthalpy change here is delta H3. Now what you need to know, or what Hess Law is suggesting, is that since these two equations, the first two, let's call this 1, 2, they all contribute to the formation of the carbon dioxide, if we don't know the enthalpy change involved in equation 3, we can pick these two and determine the enthalpy change of the carbon solid with oxygen molecule giving us the carbon dioxide. So that simply means that delta H3 is equal to the sum of delta H1 plus delta H2. So that is Hess's law. So if they are going to give you a question on this, what is it going to be like? Now let's look at this one. So the equation for the formation of propane is as follows. So we have carbon with 4 moles of hydrogen gas giving us propane, and we have enthalpy change of x kilojoules per mole. Now you are given the following data to calculate the value of x. So we have 3 equations and we need to do something about it to get the enthalpy change involved in the formation of propane gas. Okay, so we are at liberty to use the laws to manipulate this data or this information that we are given to be able to determine the enthalpy change, which is x. So what do we have to do? Alright, so when we look at the original equation, we have, let me put this here, we have carbon, 3 moles of carbon, and then we have 4 moles of hydrogen gas, H2, giving us, this is gas, giving us C3H8, that is propane gas. And we need to find its enthalpy change. Now we are given 3 equations. Now we have the first one, we have hydrogen gas with half mole of oxygen and then giving us H2O. Now we need this hydrogen at the reactant side just as we have here. So we need the hydrogen at the reactant side. So what we are going to do is, since we need 4 moles, then we need to multiply the first equation by 4. So we'll multiply equation 1 by 4. So let's say this is equation 1. We'll multiply it by 4. And what can we do with equation 2? With equation 2, we have carbon there, and we also need a carbon at the reactant side. So what we are going to do is multiply through by 3 because we need 3 moles. So multiply equation 2 by 3. So this is our equation 2. We are multiplying it by 3. And what about the last one? The last one, we can see the propane which we are interested in, but then it is at the reactant side. We need it as product, so we are going to reverse the equation 3. So we reverse equation 3. This is allowed according to the first law. So when we do all of this, what are we going to have? The first one, we are multiplying equation 1 by 4. So when we do that, we are going to have 4H2 gas plus 4 times half mole of oxygen, that is going to give us 2 moles of oxygen gas, and then we'll have 4 moles of water molecule, 4H2O, and we need to do the same thing to the enthalpy change, remember. So this is going to be equal to minus 280.5 times 4, and this one will give us minus 1122 kilojoules per mole. Now for the equation 2, we are multiplying by 3. So when we do that, we'll have 3 times carbon, we have 3 carbon solid, and then 3 moles of oxygen gas, and this is giving us 3 moles of carbon dioxide gas, 3 CO2 gas. Remember, we need to do the same thing to the enthalpy change, and so we are multiplying minus 395 kilojoules per mole by 3, and if we do that, we are having minus 1185 kilojoules per mole. And the last one, we are reversing equation 3, and the first law says that we can reverse. However, the sign of the enthalpy change also need to reverse. So when we reverse that, we are going to have 3 moles of CO2 gas, and then we'll have 4 moles of H2O liquid, and this is giving us C3H8 propane plus 5 moles of oxygen gas, and so the enthalpy change is also going to be reversed. That means that we are going to have plus 225 kilojoules per mole. Alright, so this is the outcome of our manipulations. Remember, we can manipulate the data to get the enthalpy change of what we are trying to work out. Now what is going to happen now is that we need to cancel out to be able to get our equation. So what we are interested in is 3 moles of carbon and 4 moles of hydrogen gas, giving us propane C3H8. So we look out for the like terms and then we cancel them out. So we have oxygen, we have 2 moles of oxygen here, which will cancel 2 out of these 5, leaving 3, and then we have another 3 moles here. So all the oxygens are gone. We have 5 moles of oxygen on the right, and then we have 5 on the left, so we cancel out all the oxygen. Now we can also cancel out the carbon dioxide. We have 3 moles here, we have 3 moles here, so it is gone. Now the only thing left here is water. So we have 4 moles of water here, we have 4 moles of water here. So all those ones are gone, leaving what we are interested in. We have 3 moles of carbon, and then we also have 4 moles of H2 gas, and then on the right we have C3H8, that is the propane. So since we've added these equations, we also need to add the enthalpy change. So enthalpy change here is going to be minus 1122 minus 1185 plus 2205 kilojoules per mole. And if we add all of this, we are going to have the enthalpy change to be minus 82.0 kilojoules per mole. So the enthalpy change for the formation of propane is minus 82.0 kilojoules per mole. So this is how you use these informations with the aid of Hess's law to work out the enthalpy change of a reaction. You should be able to manipulate the data just respecting the law and cancel out the ones that need to be cancelled out, and then you get your equation. I hope this video helps you. Remember to subscribe and also like, and share to your friends. Thank you.